Hey everyone, in this video, I'm just going to quickly share with you the product and quotient rules for differentiation. So first of all, if we have two differentiable functions, f and g, and we have the product of those two functions, let's define that by h. So let's say h is equal to f times g. If you want to take the derivative of h, all you have to do is follow this rule. You do the derivative of f first, multiplied by g, plus f multiplied by the derivative of g. So it'd be f prime g plus fg prime. And then the quotient rule is if you, again, have a function h, but this time it's defined by a quotient of two differentiable functions. So let's say it's f divided by g, and we're assuming that g, of course, is not 0. If you want to take the derivative of h here, or this quotient, you would do the same pattern, f prime g, except we subtract, we don't add, f prime g minus fg prime, and then you divide by g squared. Okay, so the derivative of h in this case would be f prime g minus fg prime all over g squared. So let's just see a couple examples here for practice. So using the product rule, let's say we want to differentiate the following function. Okay, so we have the product of two functions here. We've got our first function, and then we've got our second function. So you can think about that first one as your f and that second one as your g. So when we're differentiating this, remember it would be f prime g plus fg prime. So what would f prime be, or the green part prime? So take the derivative using power rule. You would get 3 minus 4x, and that's f prime. Then we multiply by g. So that's my f prime g plus f, which you just copy down the function, and then g prime. So think about how you would take the derivative for this blue part right here. Well, first rewrite that as a power. This is x to the 1/2. So now using power rule, what's the derivative of that? You would get 1/2 x to the negative 1/2. And then we can simplify. Okay, if I want to clean this up a little bit more and simplify, I can make a common denominator of that 2 root x. So we can multiply everything in the numerator on this side by 2 root x, and then the denominator by 2 root x. So our derivative would be 9x minus 10x squared all over 2 root x. Okay, let's do another example, and this time we'll use the quotient rule. Suppose we have the function 5x minus 2 over x squared plus 1. If we want to differentiate this function, in other words, take y prime, or dy dx, we're going to use the quotient rule. This top piece here would be our f, and this piece on the bottom here would be our g. Okay, so following the quotient rule, we're going to do f prime g minus fg prime all over g squared. So f prime, just take the derivative of the numerator, the top part. So using power rule, that derivative is just 5. Multiply by g. Subtract f, g prime, just take the derivative of the denominator. Using power rule, we get 2x all over g squared, so x squared plus 1 quantity squared. Okay, so we just have to clean this up and simplify, and you end up with negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. Okay, so that's it. That is the product rule and the quotient rule, and we will practice this more together in class. Thanks for watching.